Okay, let's see. Hello, everyone. Please tell us that you can see and hear me. If you can, write a plus sign in the chat section. If you cannot, write it down as well, so we know that everything is all right. Okay, I guess we can start now. Hello, everyone. My name is Alexander Nikitin. I am a consultant at the Simulation Modeling Department at NFP. I'll be replacing my colleague, Andrei Garifov, because he couldn't make it today. So, a couple words about myself. Like I said, I work at the Simulation Modeling Department, so one of my key responsibilities is developing simulation models, which I have done quite a lot. Some examples are passenger traffic model for an airport, a model of an open pit coal mine, a credit risk analysis model. As you can see, these are different models for different industries, and all of this can be accomplished with simulation modeling, as you will see throughout today's webinar. Now, a couple words about NFP. NFP is a Russian consulting firm with over 80 employees. Most of them have experience working in the Big Four consulting companies. I have that experience as well. I worked at PricewaterhouseCoopers. We have a lot of projects both in Russia and abroad. We specialize in methodology development, simulation modeling, robotization, and automation. Now, what are we going to talk about today? First, we'll briefly talk about what modeling is in general, what is simulation modeling, what is digital twin technology, how can you use it for your business, how can you benefit from it. We'll also talk about the leading simulation modeling platform, which is AnyLogic, and we'll look at some actual models developed with AnyLogic. So what is modeling? Probably all of us use models in our daily work. It's a very powerful tool because instead of just coming up with a solution and applying it right away to your real assets, you create a copy of it and you sort of play around with it. You analyze it, you think of ways that you can improve it, then you test those ways, and once you found a solution that you're satisfied with, only then do you apply it to your business. The tool that most of us use and most of us are familiar with is, of course, Microsoft Excel. We all know how it works. You write down some inputs, you specify the formulas for which will be used to process those inputs and give you the outputs, the end result, the answer to whatever question you were trying to answer with your model. This is a very powerful, very simple tool, obviously, but it's not without limitations. So, first of all, there's only so much data that you can input on an Excel spreadsheet. And that data needs to involve relationships that can be clearly defined, they are predictable, because they need to be expressed as a set of mathematical formulas. If it's more complicated than that, if it involves taking time into account, or location, or uncertainty, you can't really deal with it in a meaningful way. All you can do is either simplify it with abstraction, or you just omit it. You ignore it. And that obviously takes its toll on the quality of the model that you develop, because it doesn't accurately reflect the system that you're trying to model. And also, it creates a sort of black box effect, where when you look at a model, especially a complex model that took weeks or even months to develop, all you see is a bunch of numbers on a spreadsheet. You don't know what it does. You don't know how it works. You don't know what relationships are modeled. You don't know whether they're modeled as they are or whether they were simplified or just omitted. You don't know. Your analyst tells you that it works, but the reality is all you see is a bunch of numbers. So now that we've talked about limitations, let's talk about alternatives. Is there any alternative? Well, one such alternative is simulation modeling, which is a technique that works in a very different way. Whereas in Excel, you try to sort of fit everything together into a compact set of mathematical formulas. In simulation modeling, you just specify the way the system works now, and you watch events unfold. So you specify what objects there are in the system, you specify what parameters they have, and how they should interact with each other. And then you let it play out, and you see what happens, which is great, because sometimes you have a problem and you don't actually know how your solution to that problem will affect the system. You think it's going to work, but the reality is you cannot process all the data. You cannot take everything into account, so you have to take a chance. Well, with simulation modeling, you take a chance in a virtual risk-free environment. You see whether it works, and if it does, only then do you apply it to your real business. As you can imagine, this is quite powerful, and it provides great opportunities for forecasting, planning, investment decision evaluation, risk management, project management, and many others. So with simulation models, you can handle a lot more inputs. You can handle relationships that are way more complex. You can take time into account. You can take location into account. You can handle uncertainty and randomness. You don't need abstraction to model any of it. You can just model it as is. And that means there's no black box effect. You just look at a digital copy of the real thing, so you can be sure that it works. Now, one quick note about digital twin. What is the difference between simulation modeling and digital twin? Those are actually closely related. A digital twin is a simulation model that is up to date. It reflects system as is. So when we develop a simulation model, we try to make it look like the real thing. But as time goes on, changes happen. And if those changes are not reflected in the model, then the model becomes outdated. So if you want to keep using your model, you got to keep it up to date. If you change a piece of equipment, you got to change it in the model as well. If you sell a piece of equipment, you got to sell it in the model as well. If you keep it up to date, then you've got yourself a digital twin, which you can use on an ongoing basis. How can you benefit from simulation models? First of all, you can just use it for system analysis. If you have a very complex business, it might be hard to study it in the real life. For instance, if you have a set of open pit coal mines or a complex piece of equipment, you can't really look inside it. You cannot really study how it works in real life. But you can build a digital copy, and you can inspect that digital copy to gain a better understanding of the real business and make better informed decisions. Next, you can use simulation models for project evaluation. If you're looking at a project and you want to see whether it's worth investing in, you can apply that project to a simulation model. You can see what's going to happen, how this change will affect the system performance. And if you're satisfied with the results, then the project is worth investing in, and you should approve it. On the flip side, if you are presenting your project for approval, you can use a digital copy as a powerful presentation tool. You can show the committee that, look, this is our business, and this is what's going to happen if we approve this project. So you can see all the metrics, you can see how the system behavior will change, it's a good project. So that's quite powerful. And finally, you can use simulation models for training. When managers have to make tough decisions that affect the entire business, sometimes they lack the experience because they've never taken those kinds of decisions because no one really allowed them to. But with a simulation model, you've got this virtual risk-free environment where you can do anything you want and you can just see what's going to happen. So for instance, what happens if we build another factory or we demolish one of our factories? What happens if we drastically change some parameters? We can do that in the simulation model. We can let our managers practice and gain the necessary skills for when they need them in the real world. So what are the areas of application? As you can imagine, it can be applied pretty much anywhere. It can be applied in marketing, manufacturing, sales, finance. Whatever your business is, chances are you can improve it. You can benefit from using simulation modeling for it. Next up. So yeah, we can all think of examples of business problems that can be solved with simulation modeling. For instance, how should we arrange equipment? How many trucks we need? Should we hire workers or buy better machinery? Those are all questions that are very well answered with a simulation model. You can get solutions that you can be sure of. And by the way, if you have problems like that you're looking for a solution to, please write them down in the questions section and we'll get to them. So now that we've talked about simulation modeling in general, let's talk about what actual simulation tool you should use. Well, the tool that we at NFP use and the tool that actually is the most popular one is AnyLogic. 40% of Fortune 500 companies use AnyLogic. And it's the leading platform in the market, and you'll see why. First, it combines all the important simulation modeling techniques. It provides perfect database integration. It provides powerful visualization tools. You can create a two-dimensional copy of your business. You can create a three-dimensional copy. So there's no black box effect at all. The way we use AnyLogic is through something we call experiments. Now, those are different modes in which you use the program depending on the problems you have. So the most common is simulation, which is basically just creating a copy of the system and watching it play out. Or if you have a specific problem like finding the optimal set of inputs, which would give you the best business performance, you can use optimization experiment. Or you can just compare two scenarios, like in the project evaluation scenario we talked about. You can use compare runs experiment for that. And there's a few others as well. So really, you can solve most of your problems with one of those experiments. All right, so that is the end of our presentation, but like I said, we will see some models in a short while. But before we do, I'd like to remind you that this is but the first in a series of webinars. It's the introduction webinar. And in April, we're going to have another webinar for mining. And then in May, we'll have a webinar for metallurgy. So we would really like you to join us for those as well. All right, so now for our models. We've got three models for today. One is a concrete factory model. Then we got the airport model and the vending machine network model. All right. So everyone should see the AnyLogic UI right now. This is how it looks like when you're developing a model. And first, we're going to look at a concrete factory model. Now, this is a model that was actually developed as part of a project and later introduced into AnyLogic as a demo model so that everyone can see what can be accomplished with this tool. Now, this model is a digital copy of a real-life concrete factory. And if you get overwhelmed at first, it's all right, because there's this helpful tooltip which explains all the different processes that are going on. So you can see first we mix sand and gypsum to get the initial mix. We pour it into the forms. We wait for it to rise, which basically means it expands like flour. Then we send it to the autoclave ovens, and once it's ready, we unload it and send it to our client. Those are the basics of concrete manufacturing. And all of those processes are perfectly modeled in this model without any abstraction whatsoever. So it uses real measurements, real data. All of it is the real thing. And if we speed up a little bit, you can see the different pallets going through all the different stages. We can see the countdowns. So lots of very helpful info here. This is the 2D presentation. You can see the same thing in 3D from different camera angles. So you got total control over the presentation. You can zoom in, you can zoom out. And then if you want statistics, there's plenty of that as well, which is gathered in real time. So you can see the log of all the events that are happening. You can see graphs, you can see the downtime, you can see utilization, and then you can see state charts, which show what state different equipment was in at certain moments in time. So a lot of helpful data here that can help you make decisions. What pieces of equipment are underutilized, which of them are overutilized, what are the bottlenecks, what equipment you can get rid of. So really a lot of stuff to help you make better informed decisions about your business. And of course, it's not just one set of parameters. There's a lot of parameters that you can change at the start screen. You can change all sorts of stuff. And it's numbers, it's types of processes that you use. All of that can be modeled. So very helpful model indeed. Next up, let's look at the Aeroport model. Now this is a model that actually we developed here at NFP. This is a model of an airport in Tomsk. And the model is designed to run for 12 hours, but really you can have it run for as long as you want. So we've got our schedule of flights, and at certain times, passengers will arrive for international and domestic flights, or they're going to come back from abroad with domestic and international flights. So right now you can see some people are arriving for international flights, and they're going through all the usual processes, the initial security check, the check-in, the further security check, then they're going to go through passport control and all the way through to boarding. Now, like I said, the flight schedule is uploaded from an Excel spreadsheet, so it can be changed by users of the model to better reflect the circumstances. And also, like with the concrete factory model, there are two modes of presentation. So first there's 3D for both floors, and then there's 2D. And with 2D presentation, you've got this helpful heat signature element that shows you which areas of the airport have the most traffic go through them and which are underutilized. So if we speed up a little bit, we'll see what I'm talking about. If you see an area that has no traffic go through it, then it's basically wasted space, it's wasted money. And if you see an area that has a lot of people go through it, then maybe you should consider expanding that area. So like in this case, for example, a lot of people arrived on a domestic flight, they're waiting for their luggage, and they're bunched up together in this very tight space. So maybe it should be expanded, whereas those spaces are not used at all. So maybe you should do something about it. This is a lot of information that can be used for management decisions. Again, we've got statistics, utilization at different points throughout the airport. And here you can see the logic of this model. So 4 types of flights. You've got the international and domestic flights, and you've got the flights that arrive and the flights that leave. So all of that is accurately modeled. You can see how many people went through those blocks. You can see where they went. And you can be sure that everything is modeled the way you want it to be modeled. So yeah, very nice model that we are proud of. And finally, let's look at another model, which is a vending machines network model. Again, this is a model that we created here at NFP. And the idea is this. Our client has a network of vending machines scattered all over Moscow and some in the Moscow region. And they need to supply those machines in the most optimal way possible. Each of those machines has a certain number of units of stock in it, and those are being sold at a certain random rate. And when a machine runs out of stock, if it cannot sell anymore, then you're not getting more money. So you want your machines to be stocked, but at the same time, you don't want to stock them and then have them sit there with no customers. So you want to find the balance. And to find that balance, you gotta choose the optimal parameters. You want to look at how many trucks you use to deliver units from the warehouse to the machines. You want to see how many units you should ship to your warehouse on a daily basis so that you actually have units in the warehouse. And then you want to see how many units should fit into a machine, how many should fit into a truck, how big your warehouse needs to be. And you also need to look at how long it takes you to load a truck and how long it takes you to load a machine. So if you can find some measures to improve the loading time, you can reflect it in the model and see what sort of an effect it generates. So for instance, if you improve the business processes to allow the truck loading time to go down to 7 minutes, you can run your model and you can see how it affects your bottom line. Here are some economic parameters that you can change as well. You've got your salary, you've got depreciation, fuel consumption, and of course, the product price to balance it out because you want to see how much revenue you're generating. So that's the idea behind this model. See how it works. It's also worth noting that we've got time and date here. So we actually model shifts. So truck drivers stop working at a certain time and they don't come back until the morning. We also model lunch breaks. model breakdowns. All of that is taken into account. And we also have statistics here. Once again, we've got the overall logic of the model. First, we check whether the workday is over. If it's not over, then we should keep working. We check the stock. If a truck is empty, obviously it needs to go to the warehouse and get some more units so that they can deliver them to the vending machines. Then go to the next vending machines, check which vending machines are in need of resupply, go to them, load them up, check whether it's time for lunch. If it's time for lunch, take a break. If not, keep going. And then when the day is over, you return the stock to the warehouse, go to parking, and then go home. And that process is repeated every day. Now, we collect all sorts of statistics here. Some of those numbers are the input parameters that we chose, and some of them are gathered in real time. So if we look here, we can see how many orders we processed, how many units we delivered. We can see how many miles our trucks have driven today and in total. We can see how much delay there was. So very important metric here, one that you should try to optimize. You can see how many goods are sold. You can see how many of them were not sold because there was no stock. So if a customer comes up to a machine and they want to buy a candy bar and there are no candy bars, well, that's lost revenue. And again, that's something that we want to keep down to a minimum. So a lot of important information here, carefully modeled, carefully presented. Very useful model. All right. So, okay. So that was it for today. But if you have any questions, please do not hesitate to ask them in the questions section. Perhaps questions that you have about the simulation modeling, questions that you have about AnyLogic. If you'd like to use AnyLogic, you should also be interested to know that NFP is a certified partner of AnyLogic when it comes to licensing and training. And of course, we do projects for developing AnyLogic models. Now, perhaps you have some business problems that you'd like to solve. Okay. Okay, we've got a question. Do you have electric vehicle charging stations model requirements? Requirements are many and the needed amps not profited. Okay, so the way I understand it is you're asking if we have a ready-made solution for an electric vehicles charging stations model, right? Well, as far as I know, such a model does not exist, but like I said, you can model virtually anything, virtually any system with AnyLogic. So we can do that. We could do that for you. We could teach you how to do that. So yeah, all sounds needed. Yeah, that's true. It is a very popular trend and one that should be properly analyzed if you want to undertake such a venture. Right. Do we have any more questions? Yes, it's true. They do planning with Excel because everyone does planning with Excel. Simulation model is still a very new technology that is on the rise, and it has a lot of potential. It does a lot of things that Excel doesn't do or doesn't do nearly as well. So there's a lot of upsides to it. Right. So let's look at All right, so just to do a brief recap, simulation modeling is a new technology that can be used to solve problems that normally cannot be solved, at least not in a satisfactory way, with Excel spreadsheets. And the leading platform for simulation modeling is AnyLogic. It's a very powerful tool that can be used to model systems in pretty much any industry. It can solve a lot of very complex problems involving complex relationships with vast number of inputs. And you can solve those problems without using a lot of abstractions. You can actually model your business the way it is. If you want to model a truck, you model a truck. If you want to model its speed, you specify its speed in kilometers per hour. You don't have to use abstractions. And the end result is very clear, it's very convincing, and it's very powerful. So once again, I'm inviting you to our next webinars, mining in April, metallurgy in May, and thank you for watching. Goodbye.